this is painful. Okay, I've dropped the resolution down to 480. Okay. Much better?
Much better.
Good, all right. The wonders of Australian internet. Okay. Cool, well, I've got everything unboxed, not all of it's in frame, but this is the main thing you guys are interested in. So I got a couple of questions during the week. One was about backlash. So regarding lead screw driven machines, backlash is often a big concern because imagine you have a screw and a lead. When that turns, you need pretty much continual contact, or when you change direction, there'll be a bit of backlash, a bit of delay. So I can happily say that these units, when I move them by hand, I can only detect the smallest of backlash. And I would say that's coming actually from the coupler, not the screws. So that's not to say these won't get worse over time, but for now, yeah, there's pretty much no backlash. And as you can see, if I can move them by hand, I mean, it does take a bit of effort, but that's how good the screws are. So I can back drive them, which is awesome. So there's our things, axes. I'm going to consult the manual, which is actually really good. The Trinus guys have done a really good job on the manual. And grab my little baggie. So yeah, this is a kit. The Trinus is a kit printer. It does not come assembled. It comes in that awesome box, and you have to put it together. And this is the bag of nuts and bolts. So I'll just push these aside. So we've got spare nozzle. You're going to struggle to see that with this resolution, but that's the nozzle. So it's a bit larger than a standard E3D nozzle in my opinion, but it may still be M6. One of the Trinus guys might be able to confirm that in the chat, if it's an M6 or not. Because if it is, then you can use hardened nozzles designed for E3Ds, which is cool. Okay, go back to my instruction manual, which is frozen. Come to me, instruction manual. Computer is just dying. Good, okay. So as I said, we've got a baggie of screws. And we have our Allen keys. I did bring some extra tools. So when you're assembling things, it's pretty handy to have like this kind of thing, instead of using these, which can be a bit harsh in your hands. So, I mean, this is one's from Hobby King. It's just an Allen wrench. This one's a bit more expensive, but they're just pretty much the same thing in a screwdriver format, which are very handy to have. But the Trinus comes with all the tools you need anyway. So we've got our bolts, little machine screws, and confirm all the parts are here. So the first thing to do is to attach the feet to the base plate. So put that here. So base plate, carefully there. We've got our feet. So it says it wants one medium screw, should be this one, and one washer, should be these ones. And essentially, make sure we get it in the right orientation. I'm not sure if this plate's symmetrical or not. Kind of does look like it's symmetrical, but yeah, it looks fine. And to put our feet on, let's put the screws through. Where do they go? They go into that hole. Oh, there, okay. Cool. So the base plate's actually tapped in various areas. So, none of this awkward holding nuts in bolts like you would do assembling something like a replicator, like the first gen wooden ones. This is tapped, so it just goes in and you don't need a nut on the other side. Again, if you're just coming in, I am extremely sick, so apologies if I cough. And this one, where do these ones go? They go in the third hole. That one.
The ink droid wants to know if the feet are rubber.
Yes, they are. They're very soft, squishy rubber. No, not very soft, but definitely going to be good for shock absorption. So it should be good in keeping vibrations off the ground when you're printing, which is a nice thought from the Trinus team. There we go. That's the last one. Cool. All right. That's our feet installed. Next, we've got these metal uprights. So these are what support the Z-axis, the Z-axis, I believe. And they're just going to sit like that. And then, yeah, cool. So the screws go top down in this case. Again, they're tapped. And they want the smallest ones, which would be these ones. Little bad boys. And I really don't like resting it on the actual axes. I'm going to move them out of the way for now. Cool.
Sloan V wants to know, are the metal parts aluminium?
They are all steel except the axes, which are CNC machined aluminium. So if you can hear the sounds, so sorry, that would have been really loud for headphone users, my mistake. These are all steel, and the axes are aluminium. So it's a pretty heavy machine for what it is, for the size, but that's a good thing, right? And screwdriver. This is like the ultimate Meccano set. It's like, I think people will enjoy assembling this machine. So far, from what I can see, it's all easy to use threaded components. So I can't see anything that's going to be needing nuts so far, which means in terms of putting it together, it's just going to be a dream. So yeah, I'm kind of nerdgasming about this stuff a little bit. This is why you want high quality tools. Sticks on the end so you don't have to worry about it falling off. These are Weha Magilock precision screwdrivers. So this is the Allen key version. Weha Pico Finish. Yeah, about $10 each in Australia, but oh so worth it. And this one. Good. And keep in mind, guys, I haven't put this together before. This is the first time I've done it. So I apologize if there's some boring bits. Yep. But it'll be like you assembling when you get your kit. Although you'll actually be faster because you would have seen this and seen how to do it.
Dark 3D wants to know, what is your drink of choice while being 3D
At the moment, because I'm sick as a dog, I choose the biggest energy drink I can get hold of, which is this one at the moment. But it depends on the time of day. You know, so if I'm assembling a printer late at night, it will probably be Scotch on the rocks.
And one more.
Yeah, go ahead.
I have a question about the build plate. Because it's screwed right in the middle of the bed, is it possible to print without a raft?
Okay, so the question was about the build plate and whether you can print right in the middle of the bed without a raft. That's a good question. So you've got these screw heads. These are going to be countersunk. And I think you will get deviation when you're printing over them without a raft. So the up box is similar. It has screw heads in the bed as well. I think you could easily get away with avoiding that by just putting some build tack or another surface over the top of this. I haven't seen many printers with just straight like plexiglass acrylic beds. So I'm not sure how well this is actually going to work. It does work in their videos, but I would recommend just getting some build tack. And then you'd be able to print straight onto that. No problems at all. Right, so these ones are a little bit fiddly to get in. They're right in the corners. Again, which is why it's handy to have this awesome screwdriver. And these are all, by the looks of it, M3 or M4. No, M3. I'd say M3. So I'm not tightening these all the way down. I'm sort of leaving them a little bit loose. And even then, they're kind of, yeah, pretty close. So this is a hand machined and assembled prototype. And it's beautiful. So what you guys will get in your kit will be a lot more polished than this. And this is already amazing. So, yeah. All right, what do we got now? Yeah, so in terms of the instructions, there is heaps of diagrams. It is, I wish I could show you, but I don't want to damage this, I don't want to stuff up the stream. But the diagrams are beautiful. Really, really easy to follow. All right, we're already onto the axes. So, because these are all identical, it doesn't matter which one I grab. I can just put whichever one I want on. And we're going to start with the Z-axis. So tip that aside. And these are going to be held in place with these, which are the large screws, which I think this one works for. Success, right? So basically, again, these are tapped. So these screw into the supports. And it suggests to use 6. Something you'll notice as well, if I show you this one, all the holes. So these are modular components. There's nothing stopping you from using these in a different system. Like, I think the Trinus guys should sell these individually, like just for hackers and inventors, because you get one of these bad boys and you get a projector, you have an SLA printer. You get one of these and put another one on top and you have an XY table. I am so impressed with this approach. I don't know why someone hasn't done it before, but yeah, I think they're really onto something, and I think you're going to be seeing really good things from this company. And they have not paid me to say that. No, a little bit difficult working out which hole is actually the right one. Right. I wonder if this will hold the record for the fastest 3D printer ever assembled. What do you reckon? So again, I'm not tightening everything up all the way. When you're assembling things like this, you never tighten screws completely. You always leave them a little bit loose for the final assembly. Because not everything's perfect. Everything has tolerances. And you need to make sure you allow for them. So when you tighten it all up, everything nicely falls into space, place, thing. Any other good questions? Yeah, so the question's about if they spent so much effort into making this structure, why didn't they go the whole way with a heated print bed? I think it was a price point reason. So the machine without the heated bed is like $300 US. I mean, there's a few variations because it's a Kickstarter project, but that's nothing for a 3D printer. I mean, the only other printers below that are like the M3D and the Hobby King Fabricator Mini. And that's, for a machine of this quality, that's ridiculous. So to add a heated bed and enclosure, they have allowed that in their campaign, but to do that from the start, it would have made the price entry point much higher, which I think would have been a lot of much hesitation for people. Because a lot of people just want to get into 3D printing, want something that works, and they don't care so much about heated beds and printing ABS and stuff. I mean, I do. I want to print an ABS for prototypes, but most people don't. Like, for most applications, PLA works fine. And I think that's the reason they did it, because they could get away with it without having a heated bed and therefore sell a machine for a lot less than it would have had to be. Some of these holes are a bit tight. I'm being careful not to cross-thread them. I brought a lot of things with me, but I haven't brought an M3 tap, so I hope all the holes are tapped. But this one might not go in. He's a little bit off. What I might do is just loosen these.
Chris Warren says, surprised those linear guides aren't at 90 degrees to the base plate. Are you sure you have this course the correct way around?
No, they are. Supports the correct way around. Yeah, no, they're both identical. I haven't tightened everything completely all the way up yet. So it might just be lens distortion throwing you off, actually.
He says, looking at the photos of the completed printer, I think you might have them the wrong way around.
Okay, I'll take your word for it. Let's have a look. Their instructions show the stepper motors at the bottom, definitely. But let's double check to be sure. Okay. So these metal parts are identical. They're the same. No, that's how it is. Don't forget, all these components are identical. You can't really put them the wrong way around. So, yeah, no, it is how it is in the campaign. But thank you for caring. It would have been a disaster if it was wrong. I'm pretty sure once everything's tightened up, you will see it being accurate. Yeah. But I can't get this last screw in, which is a bit annoying. I mean, it's fair enough that things would be a little bit misaligned because it is a handmade prototype.
Okay. One of them doesn't have a Z-stop, so there's a single one that is different. One slider has no end stopper. The one with no end stopper needs to be the right one.
Oh, okay. Good point. Let's have a look. So this one's got the end stopper. That one's got one. That one's got one. That one doesn't. Good point. Good. Well spotted. And
4 slider, 3 with end stopper. 1 without. Z-axis needs to be the only one.
yeah. So I rotate it that way. Yeah. So these need to be swapped to follow their diagram exactly. Well done. Thank you for picking that up. Luckily, it won't take very long because there's just only a few screws. I'm not sure what that's going to change though, because your z-axis should be perfectly level anyway. But it's all right. We will follow the exact pictures. And it means it might actually fit this time. Yeah, so that one can go there, and that one goes there. Because this one doesn't have the Z stop, and that one does. I think might just swap this one out. Because I think the tolerances for this one of the holes is a little bit off. So in terms of attaching it to the Z axis, I don't think it's going to work. I'll just swap it for another one. Yep. So I'll swap it for this one. There we go. And this one. Okay, that looks much better. You'll notice as well, I don't have the laser engraver attachment, and that's because lasers are dangerous, and the guys at Kodama want to get all the accreditation properly sorted out first, which is completely fine by me. I wouldn't be able to fire the laser up here anyway. But that's one thing to keep in mind. It is pre-production. Some things will change, most definitely. This is a hand-made prototype, and some things like the laser and stuff need accreditation before they can be sold and shipped to people like me. And also, if you haven't seen, the campaign is now over $1 million funded. That's insane. So, well done to those guys. Well done to the Kodama team. Okay. That's good. That's good. 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 And it's the final one here. Right. Cool. All right, got there in the end. So those are those ones. And we've got our guides right at the top. So we now want to attach our, what would that be? That'd be x-axis. All right, another guide. And it will go this way, like that. Yeah, so once you attach the X, everything squares up. So you can see that? Everything's still a bit loose, a little bit wobbly. Once I attach this, it's all going to square up, which is super cool. Yep. Oh, the inner bolts. Got it. For those guys that just come in, we are assembling the Trinus Kickstarter 3D printer and laser engraver. I don't have the laser engraver unit because of safety reasons, and it's not finalized yet, but this is a pre-production unit that I am assembling. And also I am sick as a dog. So And also, as you can probably tell, I'm not in my usual location. I'm currently in Queensland. And we're streaming from my tablet, which is working now, but definitely not the most powerful computer. But it is what I have, so it's what we all use. Okay.
Neil wants to know if you have any plans printing anything today after the assembly.
So in terms of printing stuff on the Trinus, I'm going to get as much done as I can. I don't know if I'll be able to print something because there's going to be a lot of calibration after this. And for those guys who have printers, you know calibration is like where you really have to sink the time in. But what I might do is I'll get as far as I can. Obviously, I can't stream like all night. But if I do fly ahead, I'll start doing a print. But otherwise, I'll just do a print with like a time lapse or something. And do a quick review, which I'll upload tomorrow, of my findings. I'm going to flip this around. Okay, let's see if I can get those last screws in. It's a bit of a struggle lining these up.
When will you have a review out of this as well?
So, as I said, I'm going to assemble it, test it today. In terms of getting a review out, I will definitely have something out by tomorrow. Again, though, definitely keep in mind, guys, as I said, this is pre-production. So things change. You know, if I find things that aren't quite right, they're definitely likely to change in the final version. And I'm definitely struggling to get these last ones in. Really isn't going to go in. There we go, that's one. How about you? There you go. If I can't get certain screws in, I might have to move on and come back to them later. Again, just because imagine hand marking up this many points and expecting all of them to be accurate is kind of unfair. Because the tolerances they're keeping here are very tight. Like these holes are very, very little clearance.
Lays wants to know how excited you are to test this printer.
Pretty excited. So in terms of how much I want to test this printer, I've been wanting to test it over the last few days, but I've literally been bedridden. I've been so sick. So that's why I had to schedule it for today. And it's definitely one of the more interesting 3D printers I've come across. And it's good.
Was a screwdriver included?
No. So what I said at the start of the stream is these are the tools you get. So there's two types of machine screws that you need to use, and these are the Allen keys that it comes with. I highly recommend for you guys to pick up something like this. This is from Hobby King. It's just a cheap screwdriver with different attachments for use instead of Allen keys, and it makes this much easier. You can imagine doing this, it's painful. So these are cheap, and it's great that they're included, but this makes it much easier for you to get the screws in. And they're like $5. So highly recommend you pick one up, because you'll use it on all your other projects as well. Well, that looks pretty good to me. I'm just going to loosen those a tiny, tiny bit. And we're on to the next one. Cool. All right. What else we got? So this is I'm up to step 7 now. Okay, that's what that thing is. So there was a little plate, little metal plate. That's aluminium, and this is for the extruder. Yes.
Move it slightly towards the camera. Frame.
Like that. How's that?
Yeah, I think that's good.
Okay, so we need some short screws. Also, I don't have here, but I do recommend a magnetic bowl for all your screws. That will definitely help you from losing them, but I don't have that, so I do recommend it. So these are these the right ones? No, these ones, tiny little ones. This is the extruder plate, which goes like that. Excellent.
Neil asked what the extruder is on this printer.
So it looks like a custom design. I'll just show you quickly. Where did I put it? So in terms of the design of it, I think this will change a bit because there's 3D printed parts in it. But it looks a bit like an E3D, but it's a different heat sink design, different heat break. The nozzle is unusual. It doesn't look like a standard E3D. And it's all sheet metal, and it has a spring-loaded tension wheel, like that. So pretty standard, but it looks to be slightly custom. There's a big aluminium plate I can see in there, next to the heat break heatsink, so that's going to be good for keeping the temperatures stable in the actual extruder area. In terms of the gear, I can just see it. It looks like a standard sort of spur gear style extrusion gear with a bearing pressed hard against it. But yeah, I may rip this open at some point to have a closer look, but not right now because I don't want to break it. So the Trinus guys do say it can do flexible materials, and they show it in their campaign, and they have sent me some polyflex material. So we're going to see how that goes. Good. Did I put that on backwards? No, no I didn't. The top holes here are different to the bottom holes. They're slightly different lengths apart. So, yep, that looks good. Okay, what's next? Extruder. Through those holes. Oh, they are threaded. See, everything's threaded. Everything's well prepared. So that just goes on there. And it uses the short round head machine screws, like that.
Sloan asks, how many threads per inch or centimetre are the lead screws?
I cannot tell you off the top of my head, to be honest. I'm not even sure if they're imperial or metric, but maybe one of the Trinus guys might be able to answer that. In terms of other printers I've used that look similar to, it looks similar to the MakerBots in terms of its TPI, or its threads. It's not. Yeah, the Trinus guys say it can print up to 70 millimeters per second, which is, it's not too slow, but it's definitely not the fastest printers can do, and I think that's a limitation of this lead screw style design. So they're not too coarse and not too fine. They're kind of a nice in between. Okay. The question is, how do I get to those bottom ones now? How do you do that? Up from the back, right? Very cool. Very well thought out printer. And it's so sexy, it's all black. Mm. One thing you guys will have to be careful with is cross-threading the aluminium components. It's hard to cross-thread steel, but screws are harder than aluminium. So just be careful of that when you're assembling this printer. If something doesn't go, don't force it. Just back things off and realign, because if you cross-thread something on this machine, you're going to be very upset. Because, as I said, benefit of it being threaded design is it's easy to assemble. Downside is if you cross-thread something, you can't use that thread anymore. So just have to be careful. Tighten things up slightly and then do them all tight at the same time, like that. Cool. Okay, need some more energy juice.
Can you just confirm how much the printer is?
Head over to the Kickstarter site and go to the Trinus page. There's different tiers. The early bird tiers are all gone, which I think were, I can't actually confirm it for you. But I think it's $2.99 for the stock kit and extras for heated beds and the laser engraver attachment and the enclosure. There's all sorts of different tiers, so just head over to the campaign and you'll be able to see the prices. There'll be shipping as well on top of that, don't forget. It's a heavy printer, but the box is small, so it's not going to be too bad. You're not shipping air like a lot of other printers. Right, and we've got the circuit board, which actually is quite cool because it mounts there, I believe. Yes. Yeah, mounts on the back, like that. Cool, so we get some large screws. And gonna have to push this assembly down. There you go. Trinus.
Is the rod on the extruder element greased?
This one? No. It doesn't feel. Oh, yeah, there's some oil on it, but nothing too serious. So I think that's just because it's pre-production. It's easy to add some grease onto it, and I think I will when I get it back home. But yeah, for now it seems pretty dry. So there's some nice standoffs in the circuit, in the control box, and that's what I'm screwing into. Get another screw there. Yeah, so in terms of greasing rods, you definitely need to do it, but a lot of people have different preferences, to be honest. Oop, this is not going in. There you go. I just use regular old sewing machine oil. It's quite thin, you need to change it a lot more than the more expensive lithium greases, but I've never really had a problem. So you don't want to over tighten these screws because they're simply to hold this on, they're not structural. So yes, don't over tighten these ones. Cool. So just to show you quickly, that's how it's looking so far. Is that in frame?
It's just taking a while to catch up.
Yeah, fair enough.
Should be good though.
Yeah. Pretty cool looking machine. Okay.
Do you know what the print volume is?
It's about 120 cube. It's a little bit bigger, but not by a lot. So it's pretty small. Sort of roughly 125 or so. Oh, I've skipped a step. I've totally skipped putting that axis down, the Y. Which sort of makes sense. I should have done that earlier. That's right. Looks like it's pretty easy to do. So I'll just bring this back up. And some of you eagle-eyed guys will notice that there's now ball bearing supports for the lead screws, which I did mention in my unboxing. Whether or not it's an improvement over what it was before, I don't know. I thought it was a good idea. Some people thought it was a bad idea, but it's now there. And I guess if you don't like it, you could always remove them. So that's good. I like that. And stick the y-axis down.
Where is the spool mount? Where does the filament feed around?
Okay, that's a good question. So the question was, where is the filament feeder, the spool holder? There is not one. And that's because it's a pre-production unit and that design has not been finalized. There will be one for your unit if you order one, but for this one, there is no spool holder. So one of the first things I'll print is a spool holder to hold these adorable little Polymaker 200 gram spools. But for now, there is not one, and that's just because it's pre-production. They haven't designed it yet.
Have you heard anything about larger versions coming out?
No, and I don't see why there wouldn't be. It's just a matter of scaling the same thing up. But at the moment, I think the Trinus guys are being very careful to make any promises because, as you would imagine, $1 million pledged for this design alone. They want to make sure you will get a printer that works really well and you're happy with, rather than making promises for future things. Like they've hinted at a possibility for a CNC head for this design, and I don't see why that wouldn't work. It's all very rigid. But in terms of a bigger version, not announced, but I would be surprised if they didn't do it. Let's just go with that. So I wouldn't hold my breath because it's going to be a while. I mean, this machine's still in crowdfunding stage, but yeah, the whole concept is, I really quite admire it because it's completely scalable. You can make this, with a big enough rods, you can make this whole thing, 3 times the size bigger. You're just limited by the flex in those rods, which is very little. Okay, push this one back. Yeah, so each of the axes is held down with a minimum of 6 M3 screws to the base plate or to the uprights. Yes. Push it on.
Are you installing a heat bed, but also CJ Printing likes your shirt?
Oh, thanks, man. Oh, this is my, yeah. My sister gets me all the awesome shirts, crossovers. So I'm not installing the heat bed yet. I'm just going with the stock version, but I will see if I can get it done. I'm a bit worried about software support. That's one thing. The Pango software is good, but it's still a lot of work to make it seamless with this printer. So I don't know if the hotbed's actually supported yet. Is that one the right one? Yes. But I'll give it my shot. Give it my best. There's one screw left. That's the one. Excellent. One thing I might suggest to the Trinus team is to include one extra of each screw, just to avoid those people, you know who you are, like myself, who have like a workshop and the screw falls on the ground and hits your foot and then goes off into the distance and you lose it. So it would be nice just to have one extra of each, just as a spare. I don't think it'd add much to the cost. Again, I can't get this one screw down. I feel like this should have been the first thing to go down. It's right at the bottom. There we go. Excuse me. Yep. I'm trying to be careful not to scratch the rods as well with the screwdriver. Cool. So that's essentially that's most of the design done. We've got the X, Y, Z, and then it's just going to be putting the bed on and I think wiring it up. Let's find out. Cool, thanks guys. So the Trinus guys have noted the screws. It's just a nice touch. It's a nice touch having an extra. Okay, so we're up to the wiring. And keep in mind, for those who have come in late, I have never assembled this printer before. I have not even looked at the instructions in much detail. So this is the first I've actually done it. And yeah, it's been a breeze. So this is the print bed. And it's the non-heated version. You can get the heat bed upgrade, which I'm not going to install right now. I just want to keep with the stock instructions. And it installs with 3 of these, which are nice little M3 countersunk machine screws. And you install it, which way? Does it actually matter? I'm going to install it how the instructions say. Get the head out of the way. Just something worth noting, when you're back driving stepper motors by moving them, you are actually generating a current through them. So these aren't connected to anything, I'm not too worried, but I always do worry a bit when I move stepper motors attached to circuitry, because you are back driving that circuitry and that driver with current, which can blow up poorly designed stepper drivers. So if you have a machine connected up and you want to move something a lot, unplug the stepper motor. If you can't be able to doing that, just move it very slowly so there's not much current. Yes?
Trinus says remove the paper from the print bed, please.
Oh, okay, thanks guys. Yes. Okay. Yeah, so that's the acrylic cover. Yeah, that's a good point. I missed that completely. Sorry guys. Done and done. Very cool. There you go, that's the print bed. And it makes it easier to line the holes up because I can see now. Good.
Do you know the specs for the power supply?
Excuse me. Yeah, actually, so I was actually quite surprised the power supply, it's quite small. And it's so far, I don't know if it's going to be the same as the final version, it may change, but it's 12 volts and 5 amps, I believe. Let's have another look. Yeah, 12 volts, 5 amps output. So 5 amps isn't much current actually. And it's actually quite low for a 3D printer in my opinion, which is good. But I would be a little bit worried about the output that it needs to generate for a heated bed. Again, it's a small heat bed, it's not going to be too much current, but when you've got a heated element and a heated bed and 4 steppers, it may be a lot of current. But I'm sure it works fine for this. Let's grab some water. Cool. So that's the assembly done, basically. And yeah, that didn't take, how long did that take? How long have we been going at it?
About an
Hour? Hour doing it casually, making lots of mistakes. So next step is to just wire it up. And thankfully there's no soldering, there's nothing like that. All of these wires are pre-done, the looms are beautiful, they've got little shields. And I'm just going to go into the second part of the instructions, which shows you how to attach them. So as I said, where is it? the actual connections have color coding, which is beautiful because that means it's easy to work out which is which. So let's flip it around. No, I'm not going to pick it up from there. That would be a mistake. Pick it up from here. And tip them on the front. Trying to work out the best way. Side, I think. So I don't want to put any pressure on any delicate areas. So I think side's good because it's just resting like that. And I'll spin it around so you can see what I'm doing.
Don't forget to tighten the screws.
I won't. Excuse me. Okay, so we have, that is nozzle sockets, white and blue. We have power, USB power, and green is the X socket axis, red is Y socket, and yellow is Z or Z. Cool. So in terms of wire it up, I believe you just want to go through and plug them in. So for this one, it's just, so this is one of the, what is it? Oh no. I put both the limit ones in the Z somehow. Okay, so I'm going to wire it up almost correctly, and then I'll go fix that later, because yeah, it's going to take a while to undo. How did you guys miss that? I rearranged it for you. So yeah, both Z axes have the limit switch. But that's okay, because I can just show you how to wire up and I'll change it after. So that's one Z. And this is the X axis, so that would be green. Leave that one. This will be the Y. Red. Rotate around.
Apparently P42 mentioned it twice and I missed it.
Oh.
We can all blame me.
Yeah, we're going to blame the helper. I blame me being like on the edge of death and sickness for making a stupid mistake like that. Not quite sure with the actual extruder axis whether that's long enough. The wires don't really, unless they're meant to go how they're meant to go. Look at the picture. I have to go underneath it. Yeah, everything always goes wrong in my streams. Yeah, it goes underneath, that's cool. So, goes through here and up. And we've got, so we've got the stepper motor driver. This would be a heater, I believe. I mean, even the PDF is blurry for me because the computer's dying. Okay. Nice color-coded plug there. And this one. There. Right, flip them over. And there's even some zip ties included to help you zip tie everything together. So in terms of working out the movements, this one looks, don't want to move it too quickly, that looks okay. And this is not even going to move at all. And neither are these ones actually. So, okay, cool. So the only axis that moves, the only wire that moves is the y, sorry, the x-axis. So I can just tie down these other ones. But again, this one, yeah. So at the moment, my X doesn't have a limit switch. And that's completely my fault. Although, yeah, I can kind of just press it by hand, but it's not ideal. So in terms of wire management, there's probably a better way you could do it than how I've done it. There definitely would be. But just to tie it off, just use one of these here. Just to keep it out of the way. Like that. Right, and of course we've got the SD card, which is just a 1 gig one, but that's all you need for G-code. And that would go in there. Cool. And of course that's the power supply as well. So that's the 12 volts, 5 amps, and the USB cable, which is standard USB type A printer cable. That one there. Yeah. Sweet. So, let's grab the camera and bring it down for you. That's the, I think that's in shot, that's the Trinus. So yeah, I mean, this is a real thing. It took me about an hour to put it together, albeit a few mistakes, which I will correct. And I think the best way to do it now is I'm going to go back, fix my mistake, and go through the calibration, because calibration can take anywhere from 10 minutes to hours, depending on what I need to do. And I want to make sure it's printing and all that. And then you can expect a short review on my thoughts about it. But in terms of my initial impressions, this is a super well designed kit. It's probably the best 3D printed kit I have ever assembled. In terms of actual parts, there is literally only 4 axes, which are identical except for the limit switches. But apart from that, it's all identical. They are thick aluminium with ball bearings at the end supporting the lead screws. and the print volume is 125 by 125, I believe. So that's pretty small, but this machine is super rigid. I can't get over how heavy it is. So I'm going to go back, rebuild that part, and you can expect a detailed first opinion and first look and kind of review. But again, keep in mind, guys, pre-production unit, hand-built. This is not what the final version of the Trinus is going to be. It is a specially hand-built pre-production unit that I've got hold of. Many thanks to the Trinus team for doing that. But my opinions and stuff have to keep that in mind. This is not a production unit that you can buy now. This is pre-production. They're still figuring out some things. So in terms of putting it together, I had no issues getting most of the screws in. A few of them were a bit off, again, because they've been done by hand. I think the limit switch issue could be made more clear in the instructions, like with a big warning, if you're stupid like Angus, don't keep in mind one of them doesn't have a limit switch. But apart from that, I can't really pick on anything in terms of the assembly. It's really quite nice. The rubber feet are super thick, and the extruder is quite nice too. I will undo these bolts in my little follow-up review to show you inside, just to get an idea. But from first impressions, it looks like a custom-made extruder. It doesn't look like an E3D or J head that they've just slapped in. It looks pretty custom to me. But yeah, I'm going to have to call it off here because I need to go have a rest because my throat's killing me. I'm just going to flip it around so you can see me. There we go. But thank you so much for watching, guys. Again, I am terribly sorry about the low quality of the stream. I am limited to the hardware that I have. This little tablet I've had for a couple of years. It's really struggling. And I've got to say, I do have a Patreon, and it's completely optional for you guys to look at it. But by helping me buy better equipment, I can bring you better quality content. It's as simple as that. I mean, this machine is pretty old and pretty rubbish. But in terms of improving my internet, I was only able to do this because of you guys helping me with the 4G dongle, which is this thing. So this is live streamed to you because of this dongle from Vodafone, and I was only able to afford it because of Patreon. So my next tier is to get better hardware, so a better computer that can stream better and all that sort of stuff. So if you want to check it out, definitely please do. But again, it's completely up to you. I will keep doing this for free as long as I can, even if I'm on death's door. Anyway, I'll see you guys again shortly here on Makers